So moving along here, I thought we, again, would start to look at some graphs. Some of them are not really that good. Or you might think they're good, but there are some things that I hope that there are good things about them, so I don't want to totally rip on the graphs. There are some nice things about them, but in all the cases here, there's at least one thing that's wrong, and hopefully you can spot that as you start looking at the graph. So here we go. Few college students will spend big bucks for Valentine's Day. So here was a graph. It was in a college newspaper, some information about how the data was gathered. So that's something important to look at here. People were asked what they were going to spend on Valentine's Day for their significant other. You'll see quite a few of them. Over half said nothing. And we have these nice little heart candy boxes here. So what's wrong with this? What could you pick out that maybe you would change about this graph? So I'll give you a moment to think about it. Again, pause the video, maybe write down some thoughts on what you think is wrong before you hear me say what's wrong. One big thing that's problematic about this and that you want to really be careful of when you're creating graphs like this is that you might notice that when you're looking at this heart here, 55, that represents 55% of our sample. And look at the size of that heart compared to the next one that represents 30%, and the next one that represents 15%. Do you think those hearts are proportional to the sample size? So in other words, 55% is almost twice as big as 30%. Is the heart twice as big as that heart? I would say it's more than twice as big as that heart. It might be actually 3 times as big. It looks like you might be able to fit maybe at least 2 of these, if not 3 of them, into that big one. Is this particular heart more than 2 times bigger than that one? So 30% is twice as big as 15%. Our eyes respond to what has the biggest area on the page. And if the area is not really proportional to the actual size of that category, it can make readers think that that category is much bigger than it really is. And we call that something, it's called the area principle. So here we're violating the area principle in that this really big heart is disproportionate to the sizes of the other hearts, and it's making that group seem a lot bigger than the other groups than it really is. So the next graph is another example of a violation of this area principle. So here we're trying to show the amount of sales in billions of all these different chains of food establishments and drink establishments. And look at McDonald's, clearly 41 billion, that's a lot, but look at how much bigger it is than Burger King, which is 11.3 billion. So is this more than 4 times bigger than that? I would say yes, it is. Look at this. This is 4.1 billion for Starbucks compared to Burger King, which is 11.3 billion. So this is a little bit more than 2 times as big as that, almost 3 times as big. Is this more than 3 times as big as that? So is the Burger King logo more than 3 times as big as the Starbucks logo? So here again, we're using some art to really capture readers' attention. We're using the logos of the different companies. We're making them different sizes, but in so doing, we might make one group seem a lot more bigger or smaller than other groups. So you have to be really careful about that. And it's nice to have these logos, but maybe we could have just had bars that were equal in terms of width. And maybe at the very top we could have the logo that's small, so we still have the logo there, but it's just not, the whole bar isn't basically the logo. Okay. Here's a graph. So hopefully, I know I'm in the way here a little bit. Here's a graph that has some problems. Hopefully you are seeing right away what the problems are. So I'm not really sure what went wrong with this graph. But obviously, the sizes of the pies here are not really proportional to the numbers. Obviously, if we added together all of these numbers, we would get something more than 100%, and we know that with a pie chart, the slices have to sum to 100%. So this is problematic. I'm not quite sure what they were trying to show. Maybe they're trying to show something that is just not clear from just looking at the graph alone, or it might have been a genuine mistake. Okay, so is anything wrong with this next display? Okay, so this is not actually a graph, it's more of a table of information, but I just want to see if you can spot what's wrong here. So should Scotland be independent? This was on CNN. So I didn't want you to think I was just trying to say bad things about Fox News. I'm equal opportunity in terms of pulling out things from the news that might be problematic. Okay, hopefully you're seeing what's wrong here. Obviously, this sums to more than 100%. Are some people saying yes and no? Are they in both categories? What's going on? Well, it turns out that CNN made a mistake. This was supposed to be 48%, and they later corrected it. Here's another one kind of similar to that. This was on NBC, so another news source. How concerned are you about the Zika virus? So hopefully you're seeing what the problem is here. So I think they're somewhere along the way, they just, the bars were not quite proportional to the numbers. So 13% looks like it's much, there are many more people in there than 34%, and then 28% has nothing. And so lots of problems here. But again, these are things to be on the lookout for when you're trying to make sense of information. And this is why sometimes things can really be misleading and confusing to people. If the graphical displays are not created properly, if there are mistakes, if a lot of artwork is included that might obscure the actual message. So these are all things we want to really look at. And in Chapter 10, there are some other examples as well of some problematic graphs and some issues with graphs that you should be on the lookout for. This next one is just meant to be kind of funny, but there is something here I wanted you to notice. So who you're going to marry according to romantic comedies. Perhaps a question you've always asked yourself. Well, now we know it's going to be that free-spirited, total stranger you're hilariously forced to cross the country with on the way to your wedding. So that's who you're going to actually marry. Probably not your fiance. So a problem here is that and this, again, this is meant to be funny and entertaining, but, suppose that this is really serious, important information that we're trying to convey. And we see these different slices. It's nice that there is this key over here that allows us to know what those different colors represent. But what's missing here is the percentages. So I don't really know, what is this slice of the pie? Is it 30%, 28%, 35%? I don't really know. What's this slice? Is it like 1%? So having those percentages in addition to knowing something about what the percentages represent is really important when you create a pie chart. So another graph that you're learning about in Chapter 10 is something called the line graph, or sometimes we call this a time series plot. And this is just where you're looking at changes over time. So along the horizontal axis or the x-axis, you'll have your time periods, and then whatever you're measuring would go along the y-axis. And again, there are times when we might want to see how something changes over time. So here's a quick examples. So one thing I did is I compiled some data about temperature. I remember in 2016 it seemed really warm in January, on January 31st, given what I was used to from living in Minnesota. So what's the average temperature in degrees Fahrenheit in Columbus, Ohio on January 31st from the years 2000 to 2016? So I thought it would be interesting to look to see, is it getting warmer each year? Is it getting colder? Are there no changes at all? So maybe think about what you would expect to see, and we'll see if that plays out here. So as you can see, there's quite a bit of fluctuation. So there were some years where it was unseasonably warm, very warm for a January. And then in 2004, wow, it was 0 degrees, pretty close to zero. We're going up and then down and then up again and down, up, lots of fluctuation. So it's not really this nice straight line pattern where it's pretty much consistent and similar from year to year. So those are things you'd want to look for when you're looking at a line graph. How are things changing over time? So what is the big overall picture, the big overall trend? Are we having an increase, a decrease, lots of fluctuation, no change at all? Clearly in the last example there was lots and lots of fluctuation. So we not only want to look at the big overall trend or the big pattern, but we also want to look or think about seasonal variation. So what might be explaining that pattern? Are we seeing certain things that are that could be explained by something in particular? So as a quick example, let's say we're looking at farmers market sales. Well, obviously those are going to go up during certain times of the year when the farmers market is open more and when there are lots of different fruits and vegetables growing. It's going to go down in the fall and winter months. So we're going to see some type of seasonal variation. So we're going to be able to explain the trend based on what's going on during certain parts of the year. So quickly, here's a line graph from Fox News again, looking at the unemployment rate under President Obama. What's wrong with this graph? So what's the big overall picture? What's the trend? Well, it's hard to say. I mean, if we were just looking at the line, we might say, well, it looks like it went down and then it kind of went up and then it seems like maybe it didn't change that much from year to year. But there are several issues here that maybe might obscure things a little bit. So I'm wondering if you can see some of the things that are wrong here. So take some time, maybe pause the video, see if you can figure out what's going on here, see if you can notice any mistakes. One big issue here, if you look over here, 9 and 8.6, they look like they're the same. And wow, 8.6 is larger than 8.8. I learned math a different way. I thought it was the reverse. I thought 8.8 was larger than 8.6. So clearly some problems along the way in terms of plotting the information. And if we actually took this information and plotted it the right way so that the right numbers were in the right places, we would see something a little different. So down here, I'll let you read this a little bit later, but I kind of note some things that are wrong with this. And here, if we look, we're going to see something totally different. So we pulled out that same data, but we graphed it in the appropriate way. And we could see that, there was things went down and then they went up and then they kind of went back down again in a steep decline. So again, think really carefully about what's being plotted. Look very carefully to make sure the numbers seem right, that the right things are on the right axes, that the axes are labeled appropriately. Because just changing little things can really give a very, very different conclusion to the reader about what's actually going on. Okay, so I'll stop here. We have a couple more things to say about Chapter 10, and then we'll start getting into Chapter 11.